Okay, I think we can start now. Right. So we'll continue from our last class. I hope everyone has done your test quiz assignment. Okay. So it will not have taken you 10 or 15 minutes maximum. Right. Again, we will solve this problem today, and we'll start with the next portion. So the question again, where was the question? This is the roller. Roller's weight is 1000 Newton. Then its radius is 300 millimeters. Then there is a block here which is height is 150 mm. Okay, so we have to find what is the force P. What is the force P, which will just just take the roller and move in the force. Okay, so that means move in the force. Force okay. So now here, first what we do is we draw the free body diagram. So we are drawn the free body diagram. We have identified 2 points of contact. This is the point. It's the second point. Okay. Now the on the contact perpendicular direction there will be reaction. So this is first reaction. This is second reaction. So this is my free body diagram. Okay. We have to find the theta. How do you find the theta? Using geometry, we will find the theta. So that means this is R. This is also R. So this is R, this is also R. Okay. Now I'll drop a perpendicular here. So it's a perpendicular. I'll drop a perpendicular here. This distance is now R cos theta. Correct. Total distance is however R. So this total distance minus R cos theta should be 150. This height. Okay. So doing that, I'll put theta 60 degree. Okay. Now what I will do is so this also we have seen. Theta is 60 degree, so we will use that. Okay. Now my condition is this ball just have to move. How it will move? It will move when there is many possibilities. Movie in the it will just lose contact here. If when I push here, you will just lose contact here. The contact lose it. Move here. So that means when the moment it start moving, this contact has to be stopped. This is from our observation. Okay, about this point, it will just go into roll up. Roll in. Okay, that means this point of contact will be lost. So that means I can remove this force. You can remove this force. Over, I will draw an axis there. Direction. This is theta. Okay. Now what we will see? We will find the equilibrium. That means these three forces should be in equilibrium. Okay. Now let's say I can vertical effects Fy equal to 0. No, it should not be in equilibrium. Actually, the equilibrium is directly. But then why I am telling we'll use this? Okay, I will tell you. So vertical direction forces should be in 0. What is the vertical direction? All the components of the forces in vertical direction should be 0. I'll assume my up direction is positive. I can assume down also positive. It doesn't matter. But let me assume up is positive. Okay. So N1 the positive. N1 is this. This is N1. This is theta. So this is my horizontal and this is my vertical. Okay. So vertical is nothing but N1 cos theta is a positive sign. It is okay. Then down I have 1000. So minus 1000 should be equal to 0. Okay. So that means N1. So theta is 60 degree. That also I know now. N1 cos 60 equal to 1000. So that means N1 equal to what will be the N1? So do I have it equal here? So cos 60 also we know what is cos 60. Cos 60 is half. Okay. So half means it is 2000. 2000. Right. Go to 1000. So that means N1 equal to 2000 Newton. Right? Okay, so that is what. Now, what is the value of P? Now, P the value, now we can go for horizontal equilibrium. So, sum of forces in x direction should be equal to 0. All the components of forces in x direction should be equal to 0. I can assume this to be positive, right to be positive. So, I can write P is right hand side, it is positive. The right load, so it is positive. Okay, then this N1 also have a horizontal component. So that is N1 sine theta. This is the component. So that is minus because it is in this direction. Okay. My geometry. This is my horizontal component. This is my vertical component. So this is in minus direction. Okay. Minus N1 sine 60 should be equal to 0. So P should be equal to N1 sine 60. N1 is 2000 into sine 60. What is sine 60? Sine 63. No? Put 3 by 2. 1732. No. Okay. Now what is this? This is the force at which it is in equilibrium. That is, this point just equilibrium force. So if you apply any force, it is slightly more than this, it will just roll. Okay. This force at 1732, what happens is it will just lose contact. Contact lose. That is this condition. Okay. At 1732. At P is equal to 1732, it will lose contact with horizontal ground. Okay. Any P which is greater than 1732, it will lose contact with horizontal ground, but will be in equilibrium. That means it will not move. It will not move. Okay. Any force which is greater than if P is greater than 1732 Newton, equilibrium is lost. Equilibrium is lost. So the roller moves. Okay. So this is how we solve this problem. Okay, so there are two confusions here. One, ground so that you have to see that the movie you have to understand the movement. Okay, movement once you can easily do that. Okay. Now the property of this contact force is the contact is gone means the force also will vanish. Okay, if roller roll the contact is lost, there will be no force here also. Okay, so that also you have to see. Now when here now what we learn is this one is Lamis theorem. Lamis theorem. Okay. Now what is Lamis theorem? So Lamis theorem basically deals with forces which there are three forces. Three forces Lamis theorem use here. Okay. So just give me a moment. Okay, Lamis theorem. So let's say condition. So this is just a tool that will help you in solving problems. Let's say I have a coordinate and I have three forces. 1, 2, let's say 3. Okay. Now I'll call this force as P1. This force is P1. this force is P2, and this force is P3. Okay, so now let's say I know these angles. Call this is theta A. I'll do this. We call this angle theta 1. We call this angle theta 2. We'll call this angle theta 3. Okay. Now, if these three forces are in equilibrium, it will follow Lamis theorem. So Lamis theorem, it is a stupid theorem. Stupid theorem means Lamis theorem because you know this, you already know this theorem. Okay, so let's say forces are in equilibrium. If forces are in equilibrium, then we know that if I superimpose this as a polygon, those three should close. Equilibrium, I can use graphical method. To get a closed polygon. Okay, now this I have drawn randomly. Then let's just see. Okay, so this is one force. This is the other force. And I don't think they're closing now. This is the third force. Okay, so they're not closing now. So what I'll do is I will replace this force. The arbitrary version on the take a line. Okay, so this is my P3. Okay, so theta 2, theta 1. So there is always a slight change. So these are P3. Okay, P1, P2, and P3. So it should close like this. Okay, if it is in equilibrium, what will happen? It will close like this. If it is not in equilibrium, what will happen? If it is not in equilibrium, what will happen? So your blue is like this. So green is like this. And your red may be something like this. They will not close. Okay. So that means there is a resultant force in this direction. There will be a resultant force. Okay. If you remember the graphical method, okay. Now what I am using is I am using this law. This property use. Okay. This property is equilibrium forces. So this will applicable only for three forces. Theorem. Okay. So we can use this only for three forces. And the forces should be in equilibrium. Equilibrium the Lamis theory use. So what is the Lamis theorem? Okay. Now what I will do? I will superimpose this angle. So this angle is between P1 and green. P1 and green, P2 the force angle theta 3. So I'll try to create the angle there. Okay. So let me see. I will extend this. Okay. So this is my P1. So this is my P1. This is my P2. This is my P2. So this is my theta 3. Theta 3. Now angle between P2 and red is theta 2. So I can extend my red here. Then it will give me theta 2. This is theta 2. Okay. Now only one angle is remaining. This angle. Angle between green and red. Green, red to the angle. Okay. So this is green. This is red. So you can extend this green here. You can hold that angle as theta 1. Theta 1. Okay. So these are the conditions. I know what are the angles that I have. Okay. Now I will mark this angle also. This angle is 180 minus theta 1. This is 180 minus theta 1. Okay. This angle is again 180 minus theta 3. Okay. And this angle is 180 minus theta 2. Right. So we have a triangle, triangle, and we have three angles. Moon angles in K. Okay. Now what I'll do, I'll just copy this to the next slide. I will drop the unnecessary angles. So I don't need this angle. Okay. I don't need this angle also. I don't need this angle also. Okay. So I have a triangle with three angles. Okay. Now I can use sine rule. So what is sine rule? Sine rule, if you remember, it is like this. If you have a triangle with three sides, A, B, C, and three angles, alpha, beta, gamma, then this triangle should follow C upon sine gamma should be equal to B upon sine beta should be equal to A upon sine alpha. This is sine rule. Okay, so this rule has to be followed by any triangles. If you draw any triangle, so A upon opposite angle, B upon opposite angle, C upon sine of angles, A upon sine of opposite angle, B upon sine of beta, C upon sine of any triangle വരച്ചാലും നിങ്ങൾ ഏത് triangle നിങ്ങൾ ചുമ്മാ scale എടുത്ത്, so what you take a scale to take a paper, you draw a triangle, simple triangle, ചുമ്മാ random triangle you measure. Okay, measure this length, and measure this length. ഈ മൂന്ന് length measure angles. Okay, then you see the ratio of this length to this sine of this angle should be equal to the ratio of this length to sine of this angle. So it is a universal. Okay, paper triangle it should follow. So that thing I am applying here. So let's say again I know that this is P1, this length, this is P1, and this is angle. So I can write P1 upon sine of 180 minus theta 1 should be equal to, so for P2 upon sine of 180 minus theta 2 should be equal to P3 upon, so P3 is this sine of 180 minus theta 3. Okay, now we know sine of 180 minus theta is equal to sine theta. Okay, you can check in your calculator. Sine of 180 minus theta is sine theta. Okay, so this gives me P1 upon sine theta 1 will be equal to P2 upon sine theta 2 will be equal to P3 upon sine theta 3. Okay, so this is what is known as Lamis theorem. Lamis theorem. Okay, this is what is Lamis theorem. Right? This is basically a tool to help you solve. So when there are three forces which is in equilibrium and the angle between forces are like this, okay, then P2 upon sine of this angle should be equal to P1 upon sine of this angle should be equal to P3 upon sine of this angle. Okay, so I'll just copy this also there. So we'll keep, I think there's a space here. Okay, so I hope this is clear. Okay, so this is how we use Lamis theorem. Now what we'll do is we will apply this Lamis theorem. We'll try to solve one or two problems. Okay. So let's say three forces. So I'll type this. So then the question is three forces OA, OB, and OC. So O is the origin. Okay. Point O such that angle AOB equal to 100 degree. 100 degree. Okay. Then it is telling forces OA and OB are pulling the point O with the magnitude of 120 kilonewton and 80 kilonewton respectively. Okay. Find the magnitude and the direction of force OC to key point O in equilibrium. First, you try to draw the diagram. Okay. So before starting, I want you to get a feel of these forces. Okay. Now, what is 1 kilonewton? What is 1 kilonewton? Okay. 1 kilonewton is nothing but 1000 newton. 1000 newton. Okay. Actually, 9.8 kilonewton is 1 ton. 1 ton. 9.8 kilonewton is 1 ton. Now, because why? Force is equal to mass into acceleration. So let's say if it is 1 ton is 1000 kg. Okay, so 1000 kg into 9.8 meter per second gives me 9800 Newton. Is equal to 9.8 kilometer. Okay, so 1 ton has a force of 9.8 kilometer. This we roughly say is 10 kilometer. Okay, so we can say 10 kilonewton is number are using the 10 kilonewton is 1 ton. 1 ton. Okay, now what is 1 ton? And then 1 ton. 1 ton is basically 1 ton is basically a weight of an elephant is approximately 6 tons for African elephant. For elephant weight 6 ton. Okay. Now, when you say the forces of 120 kilonewton, it means it is 12 tons approximately. 12 tons of weight, 12 tons of mass. Okay. So this is approximately 2 elephants. Okay. So this just idea. You're not doing anything in this. Only thing is you have to respect the forces. Okay. Design in the building the forces, magnitude, that feel you should get. I know it has nothing to do with the solution of the problem. Okay. I'll just keep this as a side note here. It has nothing to do with your problem. In any case, if you want to, okay, it will be here. I will start on the page. Okay, now we'll try to solve this. If first step is to draw the diagram. Okay, if somebody has drawn the diagram, raise your hands, and I'll take that help to draw the diagram, finish the diagram. Okay, if somebody has drawn the diagram, please raise your hands. Diagram കഴിഞ്ഞെങ്കിൽ raise your hands. Okay, so nobody is raising hands, then I will call your names. So let's say Devdattan is there. Devdattan. Devdattan.
Yes, sir.
Yeah, Devdattan. Did you are you able to draw this? Yeah. Yes. Window is there. Okay. Now.
AOB angle is equal to 100 degree.
AOB angle is in 100 degrees. So any direction I can write, right? Draw. Angle should be 100. So let's say let me let this be my OA. OA. Now I'll go 100 degree. 100 degree is more than 90 degrees. So it goes somewhere here. So 100 degree, right?
Yes, sir. Then OC, okay. Anyway.
So this is what the point is about B, right?
Yes, sir.
This is 100. Okay. Now what? I have what magnitude of solvent? How is OA as a magnitude of OA and OB? OA is, what is the value of OA?
120.
120 and OB is
80 km.
80 km. Okay, right. Find the magnitude and direction of OC to keep the points in equilibrium. Okay. So the question is, how do you find OC such that the points will be in equilibrium? Yes. Did you find that?
No. Just drawn the diagram.
Okay. Now we'll solve this. Please solve this.
Okay.
Okay, I will solve this visually now because I have the tool to solve this visually. You guys solve it. Lamis theory uses solve it. Okay. So what I can do is I can take this force. I can take this force. I can move it here. Okay. So if they are in equilibrium, then my resultant should be in this direction. This direction. Okay. So I'll copy this resultant. So this should be the result. But this is by graphical method. We don't want to solve by graphical method. Okay. So what we will see is, it's Lamis theorem you see. Let it be here. Graphical solution. Sorry. So there is some line. I don't know that line is. Line the magnitude direction on. So let this be here. So let's say I will not make it smaller. So it is easy for me to draw. So this is the question. So question is find the magnitude and direction of OC. So this is my C. So you have to find the direction and magnitude of OC to keep the point O in equilibrium. Okay, but if the direction of force and what they are given is only this force. Now, how do we find this? If someone has solved this, you can raise your hands. If someone has solved this, we can raise your hands. So I will give you some clues. So I will just say, blunt light is the angle. So let this be some beta angle. Let this be some alpha. Okay. So what I know is A upon sin alpha should be equal to B upon sin beta should be equal to C upon sin alpha. Okay, so I'll take two equations, solve it and find the value. Then one more thing I know is alpha plus beta plus 100 should be equal to 360 degree. Okay, so I can use this to solve. So there is Lamis theory use there are other ways of solving it, but then try. I'll give you 5 minutes. To solve the angle, you raise your hands. So what is the other way of solving it? The method I have. So one graphical method we solve it. So this is a graphical method. Definitely this. There is one more method in which we can solve this. Lamis theory use ചെയ്യുന്നില്ല. So that the other method is this 100. So I think this method first we can solve because it is more easier method to solve. 100. Okay. So there are two forces. What is the resultant of the force? A force is the resultant. So this is a resultant. So this is first force. This is second force. You can use school rule use. This is 120 kilonewton. This is 80 kilonewton. Okay. And we know that resultant should be equal to 120 square plus 80 square plus 2 into 120 into 80 into cos 100. So first class will be So what is the result? We can solve this first. Okay. And then if there are two forces separated by angle theta, then resultant should be a square plus b square plus 2ab cos theta. Hello. This is equal to r square. We have already seen this. Okay. So with this we can get the magnitude of resultant. You can do that also. So what is the value of r? Magnitude and the. So this is r square. R square is equal to 120 square plus 80 square plus 2 into 120 into 80 into cos 100. So what is this value? This value. This solve. I will solve it. So this will be, I'll solve this.
See you, sir.
Okay. Okay, 132.162. Okay, these two force in the resultant will be 132.16. Okay, so this is the resultant. So that means these two forces I can replace by a single force. These two forces I can replace by a single force. So just copy this. What is this? So I don't know what is the angle. Okay. So this I can replace by some force like this. Whose magnitude is this. Okay. And the magnitude is this value. This is the magnitude. 132.16. 32.16. Okay, so these two forces I am replacing by some force. This. Hello. So this is same. This is same. So this is my O. This is some, let's say, some R. So these two forces, E and the forces, so I am replacing with this force. Now this is my point. So in this way, if you solve it, is very easy. Okay, this ball is there. It is going like this. So there is only one force of magnitude 132.16. Okay, so I don't know what angle is this, angle, but I have seen the magnitude. Now why this is helpful? Either one directional force. Now, if this has to be in equilibrium, we know that by common sense we can draw my forces which is putting this in equilibrium should be in this direction. So this is my C. This is my C equal to 132.16 kilometer. Okay, the magnitude of my force I know. I don't know the direction. Okay, if it is 132.16 direction push, I have to pull it back with some forces which is equal to this force. ഈ ഡയറക്ഷനിൽ 132 കിലോമീറ്റർ കൊണ്ട് പുള്ളി ആണെങ്കിൽ ഈ ഡയറക്ഷനിൽ തിരിച്ച് 132 പുള്ളി ചെയ്താൽ മാത്രമേ അത് ബാലൻസിലാവുള്ളൂ ഈ പോയിന്റ്. അതേപോലെ തന്നെ ഈ രണ്ട് ഫോഴ്സിനെ ഇറ്റ് ഈസ് സെയിം ആസ് ദിസ് വൺ ഫോഴ്സ്. Now this point is being tried. This point on O, the total force acting is 132 kilometer, right? So that means I have to pull it in the opposite direction with same force 132.16. Okay, so that means I have got the magnitude of CS 132.16 kilometer. Okay, ini ningalku orientation easy ആയിട്ട് കണ്ടുപിടിക്കാം. So this method you have to use both. നിങ്ങൾ ഇത് രണ്ടും കൂടെ ചെയ്താലേ നിങ്ങൾക്ക് സോൾവ് ചെയ്യാൻ പറ്റുള്ളൂ. Right? So this will remove. Now I know from my previous I'll use Lamis theorem. So let's say 132 C upon 100 should be equal to B upon sin, it should be sin 100. Sorry, should be equal to A upon sin alpha. So I'll just take these two. I can get the value of beta. I can beta the value or angle I get on. Okay. So what I'll write 132.16 upon sin 100 should be equal to. So what is B? B is 80. 80 upon sin beta. So this gives me sin beta is equal to 80 upon 132.16 times sin 100. Okay. So this is equal to. So I'll just solve this. 80 upon 132.16 times sin 100. 0.59. So that means beta is equal to sin inverse of 0.59 is equal to. So നിങ്ങൾക്ക് sin inverse calculate ചെയ്യാം 36.1. 36.15 degree. So we got an angle beta is 36.15 degree. അപ്പോൾ നിങ്ങൾക്ക് ഓർമ്മിച്ചു. Okay, so this is how we solve this problem. നിങ്ങൾ രണ്ട് പ്രോബ്ലം നിങ്ങൾ കണ്ട് യൂസ് ചെയ്യണം. Okay, right? I'll give you some more problems as today. Maybe random mono problem because time is over. You solve the same problem you solve. Okay. Is there any doubts here? You can ask any doubts. If you want me to repeat this, I can repeat this again. But if there is any doubt, you can specific doubts you can ask. Then first time solve there could be this could be little difficult. But the idea is like this. Okay. I have two forces separated by an angle. So I have two forces separated by angle. What I did was I replaced these two forces by one force. Replace this force by one force, E force. Okay. So this we have already we have already done in our previous class. But if you don't remember this formula, the formula is if two forces are separated by some angle theta, a square plus b square plus 2ab cos theta and resultant formula, magnitude of the resultant. Okay. That's 132.16. So that means these two forces I can replace by one force of 132.16. And the original object in the force should be in opposite direction. And the OC the force should be in opposite direction. I know the magnitude of that force because it is in the equal and opposite direction. Is going to be okay. So that means C is equal to 132.16. Now I am applying Lamis theorem to find the orientation. Okay. So I'll give you some more problems with this. Try to solve this problem. Problem solve. Okay. So I think we have to end the class now and cut the class on the phone. So if you have any doubts, if you feel not asking in front of everyone, നിങ്ങളുടെ ഫോമിൽ ഞാനൊരു ഓപ്ഷൻ തരുന്നുണ്ട്. You can ask in that. Okay. Attendance form. So please fill the attendance form. Please fill the attendance form.